Welcome to the Unit 7 Part 1 test review. First thing we covered was factoring, and we covered the sum and difference of cubes. So first I have 8x cubed minus 27. Now remember, you're going to want to think of this as perfect cubes. So when I see 8x cubed, really, that's 2x, all of that cubed. And when I see 27, that's really 3 cubed. And then I'm going to plug into the formula. 2x minus 3 4x squared plus 6x plus 9. Remember, we do have that trick SOAP, same sign, opposite sign, always positive. Now, for number 2, I'm going to do the same approach. I'm going to first get a GCF of 2 out of 2x cubed and 16, leaving me with x cubed plus 8. My a term is going to be x. My b term is going to be 2. I end up with 2x plus 2, x squared minus 2x plus 4. Now, number 3 is a approach that we took originally where I do grouping. So I'm going to group the first two together, group the second two together. My first group has a GCF of x cubed, leaving me with x squared minus 9. My second group has a GCF of -1, leaving me with x squared minus 9. Remember, the goal is that your parentheses match. So once my parentheses match, I can pull it out as a factor, leaving me with x cubed minus 1. And here is a really tricky problem because you do have to go further. X squared minus 9 is the difference of squares, x plus 3, x minus 3. X cubed minus 1 is a difference of cubes. My a is x, my b is 1, so I plug that into the formula and I get x minus 1, x squared plus x plus 1. Then we moved on to simplification with multiplication and division. So the nice thing about multiplication and division was that you did not have to find a common denominator. All you had to do was cancel out factors where you had the same factor in the top and the bottom. So let's look at number 4. So I went ahead and factored everything. Remember, when you just have a factor by itself, we think of that as over 1. I factored my numerator of my second term, that was x minus 1, x plus 3. Factored the denominator of my second term, which was x plus 1, x minus 1. Now remember, anytime you have division, you're going to keep the first fraction, change it to multiplication, and then flip the second fraction. So this x that was in the denominator is now in the numerator, and this 2x plus 6 I factored and I moved it to the denominator. I flipped the position. Now from here, it's just some cancellation. I'm going to go ahead and do that for you. I have x plus 1s cancel out. I have x minus 1s cancel out. And I have x plus 3s cancel out, leaving me with x over 2 as my final answer. Now another thing that you have to be careful of is making sure that you state your undefined values, and you want to do that before you start canceling. And remember, it's always the denominators. So I don't have a undefined value from 1, but I do get a -1, a +1. And remember, anytime you are dividing, you are going to consider this to be the entire denominator. So we do the numerator x, which gives us 0, and the denominator -3. Now for number 5, we do have another one of those keep, change, flip problems. So I'm going to factor everything and I'm going to keep, change, flip while I'm at it. Now you do have to be careful with some of these factorings because you do have to split the middle term for them. Now we are just going to go in and we are going to cancel out. Again, make sure that you state your undefined values before you start canceling. I will pull undefined values from my first denominator, my second denominator, and my second numerator prior to any cancellations that I am doing. And I'm just canceling everything out that has the same factor in the numerator and the denominator, leaving me with just x plus 1 over x minus 1. Now for number 6, I do not have any division, so I do not have to keep, change, flip. I do have to factor everything, and I do have to state my undefined values. This is one that's just multiplication, so I am just going to look at both denominators. I get a -2, a +2, and a +3. Then I do some cancellations. I see I have 2x plus 2s. I see that I have 2x minus 3s. And remember, you cannot cancel if they are next to each other or on the same position, numerator or denominator. So I do have to keep these x plus 2's there. X plus 2 times x plus 2 all over 5 times x minus 2. Then we moved on to simplification with addition and subtraction. So to simplify, you have to, when you're adding and subtracting, you have to have a common denominator. So they have to be the same. The nice thing about number 7 is I already have the same common denominator of a squared plus 4. So I just have to combine my numerators over that common denominator. So 4 plus a squared plus 8 all over a squared plus 4. Do some simplification. I get a squared plus 12 over a squared plus 4. Neither of these factor in any way where I could further cancel. So that is my final answer. I do have to check my undefined values. Now, this is a special case because when I set a squared plus 4 not equal to 0, I'm going to get a squared cannot equal negative 4. If I take the square root of both sides, remember anytime you take the square root of a negative number, you're going to get an imaginary number, and you can't have an imaginary restriction. So if you stated that there were no restrictions, that would be okay. But also if you stated a cannot equal 2i, that would be okay too. So for number 8, we are going to start by factoring. Let's go ahead and get that ball rolling. I factored this to be x plus 2 times x minus 3. Now it's kind of hard to tell, but my second fraction had x plus 2. They were missing the x minus 3 term, so I gave it to it in the top and in the bottom. And my first term has both of what I need. Wrote everything all over the common denominator, x plus 2, x minus 3. Be careful and make sure that you're not only distributing the x to both terms, but you're also distributing this negative. So it's negative x times x, negative x squared, negative x times negative 3, which is positive 3x. Now, I cannot factor this numerator any further, so that is going to be my final answer. Also, do not forget, when you are just simplifying, you do still need to include those undefined values. So I have negative 2 and positive 3. Okay, for number 9, we are doing a similar method. We are going to try to find a common denominator first by factoring. I see that I get x plus 2, x minus 2. My second fraction already has x minus 2, so all I need to do is add x plus 2 to the top and x plus 2 to the bottom, because remember, this is just like multiplying by 1. Now that I have a common denominator, I just combine my numerators. Do not forget to multiply. 1 times x, 1 times 2. I get x plus 2 all over x plus 2, x minus 2. Now, I end up with 2x plus 2 in my numerator, which I could take out a GCF and get 2x plus 1, but nothing's going to cancel out, so I'm going to go ahead and leave it as is. My two undefined values are positive 2 and negative 2. For number 10, I'm going to factor my denominators. We have a little bit more work here. My first denominator has a GCF of 2 with x minus 1 left over. My second denominator factors into x minus 1, x minus 3. Now, there are a couple of things missing for each fraction. So the first fraction is missing x minus 3, so I multiplied by that top and bottom. The second fraction is missing 2, so I multiplied by that top and bottom. Another thing that I did, which I didn't have to do necessarily for this one because I don't have to factor the numerators, was I did factor out this negative 1, but if you didn't, we should still end up at the same answer. Now that I have my common denominator, I did some multiplication. Remember, you're going to have to FOIL if you have addition or subtraction. So x times x times 2, negative 3 times x, and so on. I get my numerator written out, combine like terms, which becomes x squared plus 3x minus 4. That does happen to factor to be x minus 1 times x plus 4. And this is one of those problems where I do have something that cancels out. These x minus 1s go away, leaving me with x plus 4 over 2 times x minus 3. I do have two undefined values, positive 1 and positive 3. Now for number 11, I do have two denominators that are different, so both fractions need the missing piece. 8 needs n plus 2. N plus 2 needs 8. I get my common denominator. Do not forget to FOIL. Combine like terms, that becomes n squared plus 4n minus 20. Does not factor. All over 8 times n plus 2, where n cannot equal negative 2. Now we're going to move on to some simplification with division. Remember, anytime you see something like this and it freaks you out and it looks weird, start off by rewriting it. Rewrite it in a form that you are comfortable with, the division symbol. I went ahead and did some factoring along with the rewriting. I factored everything and I rewrote this just using division, not even keep changing flip at the same time, just division. Once I had it factored and written out, I went ahead and did the keep change flip. So I kept the first fraction, changed it to multiplication, flipped the second. Yes, I could go in and factor x squared minus 4 more, but I do know that something's going to happen and things are not going to cancel out in the way I want it to. But for now, we can cancel some stuff out that we see. The x plus 2's are going to go away. And I believe that is about it. Yes, that's all that's going to cancel out for us. So that's going to leave me with 2 times x minus 4 all over x minus 2, x squared plus 4, x squared minus 4. And I do have 4 different undefined values. It is okay if you write negative 2 and positive 2 as plus or minus 2 and plus or minus 4. Now for number 13, you do have to do a little bit of combination before you can actually do the keep change flip step. So I'm going to go ahead and first rewrite this as 3 over x plus 5 divided by 2. And I went ahead and gave the 2 the factor that it needs, x plus 5 in the top and x plus 5 in the bottom, so that I can combine it to be 2x plus 11 over x plus 5. Once I have that simplified fraction, I move into the keeping the first fraction, changing it to multiplication, flipping the second. So that 2x plus 11 from the top is now in the denominator. The x plus 5 from the denominator is now in the numerator. Go through, cancel out what I have in the top and bottom, leaving me with 3 over 2x plus 11. X cannot equal negative 5. X cannot equal negative 11 over 2. Now, number 14 is going to be solving. It's going to look exactly like simplification. The only difference is we are going to cancel out the denominator so that we are only solving with the numerators. So you're going to want to create a common denominator. Now for number 14, our common denominator is going to be x times x minus 4. So I need to make sure that every denominator of every fraction that I'm dealing with has this least common denominator. So my first fraction needs x top and bottom. My second fraction needs both x and x minus 4. And my third fraction just needs x minus 4 top and bottom. Now, once I have created this common denominator, I multiply through by the least common denominator, and I'm left only with my numerators. So I do go through and multiply. So the x is going to distribute, the x minus 4 is going to distribute, and the 3x will distribute, leaving me with 2x squared minus 7x equals 0. I do have a GCF of x. So x times 2x minus 7 is equal to 0. That gives me two possibilities for solutions. X could equal 0 or x could equal 7/2. Well, if I look at my undefined values from my common denominator, I've stated that x cannot equal 0 and x cannot equal 4. So this is an extraneous solution. The only one that's going to work is 7/2. Going to do a similar process for number 15. The least common denominator in this situation is x times x minus 2, meaning that x cannot equal 0 and x cannot equal 2. Once I get the least common denominator, I cancel it out, and I'm left with 10 plus 4x minus 8 equals 5x. I get x is equal to 2. Well, we said x cannot equal 2, so this problem is going to have no solution. Now, for 16 and 17, you just have to do a little reverse thinking. You just have to look at what you have in the end and try to imagine what you may have started with. So, the first thing I always suggest doing is creating a fraction bar and filling in the missing pieces. So, I'm going to show you my final answer. Each piece is corresponding to some factor in your answer. And notice that it's going to say, keep this in factored form. Do not multiply it out, leave it in factored form. So my final answer ended up with x over 3. So I know in my original question, I had to have x over 3 somewhere. Now, another thing that's stated is that I have x cannot equal 7. Well, if I have x cannot equal 7 and it's not in my final answer, that means it got canceled out. That means it had to appear in both the numerator and the denominator. And in order to get a positive 7, my factor had to be x minus 7. So I put x minus 7 in the numerator, x minus 7 in the denominator. Same thing goes for x cannot equal negative 4. If it's not in my final answer, that means I had to cancel it out. So I have x plus 4 in the numerator, x plus 4 in the denominator, and that's all I need. Done with the problem. Now looking at number 17, it does get complicated just a little bit more. Now, I have 4 over x plus 9 as my final answer. Well, if I have x can't equal negative 9, that's going to correspond to a factor that I already have there. Now, it would not be wrong if you were to go in and add in an additional x plus 9 over x plus 9. That is okay. But you don't have to because I already have this factor here in the denominator. Now, 1/2 gets a little bit complicated because in order to get a positive 1/2 as a solution, typically I'm ending up with 2x minus 1 as the factor that I'm setting not equal to 0. And again, if it's canceled out, that means it had to have appeared in the numerator and the denominator. X minus 3 is going to correspond to x plus 3, so I place that in the numerator and the denominator. And the last couple of problems we are going to cover are your applications problems. So for number 18, Mr. Jacobs can grade a class set of tests in 5 hours. Ms. Contreras can grade them in 3. How long would it take them to grade a class set of tests together? So I have an original starting equation of 1 over 5 plus 1 over 3 is equal to 1 over t. Now, I approach this in a way where I am solving just a regular rational equation. So I'm going to get a common denominator, which is going to be 15t. So I give everything what it needs so that it has a common denominator. So the first one needs 3t, second one needs 5t, and the third one needs 15. Once I have that taken care of, I can go through and I can cancel out that common denominator, leaving me with 3t plus 5t equals 15. 8t is equal to 15. So t is equal to 1.875 hours, or you could say 1 hour and 53 minutes. Now, for 19 and 20, I did cover these as a part of one of our warm-ups, so I'm going to go over these rather quickly. Mrs. McGurran made 25 out of 35 shots. How many does she need to make consecutively to raise her shooting percentage to 80%? So we do 25 plus x over 35 plus x is equal to 80 over 100. First fraction needs 100. Second fraction needs 35 plus x. Cancel out that common denominator, leaving me with 2500 plus 100x, because you have to distribute, is equal to 2800 plus 80x, which comes out to 15 additional throws. Now, Miss Curry is rowing 10 nautical miles per hour in Stillwater. She can cover 35 miles going downstream in the same time it takes 25 miles upstream. What is the speed of the current? So I set up my distance, rate, and timetable. I know that she can go 10 miles per hour, and either the current is working with her when she's going downstream, or it's working against her when she's going upstream. So 10 plus C, 10 minus C. And I know she's doing this in the same time, so T1 is equal to T2. So I set up 35 over 10 plus C is equal to 25 over 10 minus C. Create that common denominator, cancel it out. It gives me 100 is equal to 60C. And remember, you can use your calculator for these multiplication and division symbol parts of your problem. So the current is about 1.67 miles per hour.